Hey guys, welcome to the video about graphing vertex form of quadratic functions. We are in Unit 7a. Our essential question is, what can vertex form tell me about the quadratic function? So back in Unit 3, 4, and 5, we spent a lot of times talking about lines. And I'm going to switch over to Desmos just to kind of remind you what we learned. So we learned three different forms of a line. We learned slope-intercept form, which is y equals mx plus b, which is the red line. We learned point slope form, which is the blue line, which is y minus y1 equals m times x minus x1. And then we learned standard form, ax plus by equals c. Now when we learned all three of these forms, we learned how to go back and forth between all of them. So if you notice on the graph here, they're all exactly the same exact line. Now those gray points popping up are just some points that cross. They're just picking out random, like Desmos is just selecting a few points that they all cross at. So as you notice, they're all exactly the same line. The blue, red, and green line are all the same. They're written in a different form, but they're all the same line. And so today I'm going to introduce you to vertex form. Now yesterday or the previous couple days we've talked about standard form, which is ax squared plus bx plus c. So I'm going to go ahead and write that down. It's going to be y equals ax squared plus bx plus c. And we also remember y as also being f of x. So you can see it either way. Okay? So you can have f of x or y over there, but they both mean y. But you have ax squared plus bx plus c. Now we learned, okay, what did we learn about standard form? Well, we learned a couple of things from standard form. There are two things I know without even having a graph. I know whether this quadratic will either open up or open down, and that's based on the a value. So if a is positive, it opens up. It makes a smiley face. If a is negative, it opens down. It makes a sad face, okay? So we know whether it's going to open up or down just based off the a value. I also learned that the c value is what? Is the y-intercept. So if the c is negative 5, that means my graph is going to cross the y-axis at negative 5. Okay? Now today we're going to talk about vertex form. So remember when we had point slope form? Well, why was it called point slope form? Well, because there was a point and a slope in it. So vertex form is called that because it has the vertex in it. So I'm going to go ahead and write down the equation here for you. So that's going to be y equals a parentheses x minus h parentheses squared plus k. Now notice there's also a square on this one, the 2 exponent, because quadratics have an exponent of 2, okay? Now, this is vertex form. Now, every equation that we graph in this class, if we want it to be able to graph or have some type of meaning, there's always an independent and a dependent. There's always an x and y in every equation that we graph, okay? Typically. Now, what are the two new letters that we haven't really seen before in a form? We've never seen h and k before. Well, h and k represent my vertex. Okay, but the vertex is known as h comma k. All right. Now, h comma k is the point. It's still x, y. Like you still have the x comma y here. But what do you notice about the h value? Inside the parentheses, there's a minus in it, but over here, there is no negative sign. So you have to remember the h is opposite signs. But the k is a regular sign, okay? So for vertex, you have the point hk. Like I already know the vertex without even graphing this, without even graphing the equation, okay? And then I also know one more thing. Now let me see if you can see it. Looking at these two equations, the standard form in blue and the vertex form in purple, what letter do they both have in common other than x and y? They both have the letter a. Both forms have a. And the a is the same in both. So, if in standard form your a value is 3, then in vertex form it is also going to be 3. So I'm going to hop over to this and show you an example of what this might look like. All right, so I'm going to get rid of all of these lines. I'll just kind of give you an example of what I mean by forms here. So I have them written all the way at the bottom here. Okay, now the first equation is written in standard form, okay? Now in standard form, I know two things. I know whether it opens up or down or what the y-intercept is. So here my a is positive 2. So I know that this quadratic is going to open up. My c value is positive 10, which means it's going to cross the y-axis at 10. This is vertex form, the one below it. Notice what my a is. My a is still 2, okay? A is still 2 here. A is 2 in the first and a is 2 here, so they're both the same. But these have different numbers. I don't have 12 and 10 anymore. I have something completely different. Remember, this is vertex form, so they're showing you the vertex without even graphing it. So my vertex here would be the point positive 3, negative 8. And I'll plot that point really quick for you. Positive 3, negative 8. Okay, now that point is going to be right here. And I'm going to show you that that is the vertex. Okay, so I'm going to go ahead and plot the standard form. So the standard form is the one that's in purple. So notice that it goes through the vertex at that red point. That's the vertex. See, I didn't know that in the purple form, but I knew it because of the second equation. So again, these two equations are the same, but they look different. Now, what's the y-intercept of this purple one? Well, if I tap on the y-axis, it tells me 0, 10. And I knew that because in the equation, the c value is 10. Okay, now let's go ahead and take off purple and put the black one down. Okay, now I knew that this was going to open up because my a was positive 2, but I also knew what the vertex was going to be. It was going to be positive 3, negative 8. Remember, the number inside the parentheses is opposite. So if it's negative on the inside, it's positive on the outside. But the number on the outside is exactly the same. So it's going to stay negative 8. Okay, so let me go ahead and get rid of that red point and show you the purple and the black at the same time. What do you notice about both forms? They're the same exact graph, they're just written in a different way. Now in the next few lessons, we'll talk about going back and forth in between these two, but just for today, we're learning how to graph vertex form. So I was just kind of showing you what's really happening here. Okay, so we're just going to practice with identifying the vertex and the axis of symmetry. Now I know these two things without even graphing it because they are in vertex form. Now what does vertex form have that standard form doesn't? Well, vertex form has parentheses. Standard form does not. Standard form just has 3 terms, and it goes from biggest exponent to smallest exponent. Whereas vertex form has parentheses, and it tells me the vertex. Okay, moving on. Gonna fix those real quick. All right, so let's look at number 1. Y equals 2, x minus 4 squared plus 3. Now, let's go ahead and just answer the question, will this open up or down? Now, in order to figure that out, let's go ahead and write down vertex form. Y equals a, parentheses, x minus h squared plus k. Because I know we don't know it super well yet. Okay, now remember, to know if something opens up or down, you want to look at the a value. Well, what is a here? It's positive 2. So this is going to open up because our a is positive. Okay. Now let's go ahead and identify the vertex. Well, the vertex is going to be, what do you think? Is it going to be negative 4, 3, or is it going to be positive 4, 3, or positive 4, negative 3? What do you think? Okay. Well, remember, the vertex is always h comma k. So our h here is negative 4, but remember, we just want the h, so that's going to be the 4. They're going to be opposite. Okay. That h is always going to be opposite. But the k is going to be exactly what it is, so it's going to be positive 3. Now, axis of symmetry. Now, I know this because it's always the x value of my vertex. So it's going to be x equals 4. Remember, this number is always the same as that number, the x in your vertex. All right, starting with number 2. What is our a value here? That'll tell us whether it opens up or down. Well, our a value here is negative 1. So it's going to open down because it's negative. A is negative here. Okay. Well, what's our vertex going to be? Well, our vertex is going to be negative 2, negative 1. So it's going to be the opposite of the one in the parentheses, but exactly the same from the outside one. And then what's our axis of symmetry going to be? That's going to be x equals negative 2. All right, moving on. The next one here, we have negative 3x plus 2 squared plus 4. Do you think this is going to open up or down? This one is going to open down because our a here is negative 3. Okay, now just identifying our vertex here, it is going to be the point negative 2, positive 4. Okay, remember, it's the opposite inside the parentheses. And then your axis of symmetry is always x equals whatever the x value is of the vertex. So it's going to be negative 2. All right, so moving on, we're going to actually start graphing now. So I only have 3 examples here of graphing. And graphing is exactly the same as standard form. So graphing vertex form is the same as graphing standard form. You're going to type it in the calculator regardless. Okay, so right now I have y equals x plus 2 squared plus 2. Now without even graphing this, do you think this is going to open up or open down? It's going to open up because I really have a positive 1 here, so it's going to open up. Now I actually can already identify the vertex. Now why am I able to identify it? Well, because it's in vertex form. Remember, vertex form is the one with the parentheses. Standard form doesn't have any parentheses. So if this is vertex form, then what's the vertex without me even graphing it? It's going to be the point negative 1, positive 2. Okay, remember it's opposite in the inside, and your x always comes first. So that means my axis of symmetry is going to be x equals negative 1, because these numbers are always the same. Okay, so when we put this in the calculator and we go to our table, right, we're going to make a table, and we always have to look for the middle of that rainbow in order to graph it. Well, the middle of the rainbow, remember, is the middle point of your parabola, the middle point of your quadratic, and that middle point is called the vertex. But I already know the vertex, so instead of having to search for the middle of the rainbow, I already know that it's going to be negative 1, 2. But if you don't believe me, I'll go ahead and show you. So I'm going to type this in the calculator. I'm going to type in parentheses x plus 1 parentheses squared plus 2. Okay, so I'm going to go over, that's not the camera. All right, let me move some things out of the way. Okay, I'm going to go to y equals, because I want to graph something, parentheses, and if you want to put the 1 in the front, you can, but you don't have to. X plus 1 parentheses squared plus 2. Is that what I had? Yes, that's the equation that we have. And then we want to go to the table, which is here, so we're going to do second graph. All right, so now I'm given all of these numbers. Now, it's not possible for us to graph something in the hundreds with the tiny graph that we have. So I'm going to scroll to where there are smaller numbers. Well, remember, oh my goodness, I'm going to get rid of Desmos. I already knew what the vertex was without starting because the equation has the vertex in it, negative 1, 2. So let me search for negative 1, 2. It's right here. Now, if I look at all of my blue values, is 2 the middle of the rainbows? Yes, it's the only one that doesn't have a twin. So my vertex is correct, negative 1, positive 2. And I'm going to type in I'm going to write down the 2 numbers below it, and then I'm going to write down the 2 numbers above it. So I'm going to go to my table here. And I'm going to have, let's see. Let's go ahead and make this red because I knew that it was already going to be that. So that was knowledge that we knew beforehand. Okay. So we have below 0, 3 and 1, 6. Above we have negative 2, 3 and negative 3, 6. All right, now I'm going to plot all these points. So graphing it is exactly the same. The only difference is that I know my vertex before even starting. Whereas when I was graphing standard form, for example, I didn't know the vertex until I graphed the entire thing, right? I didn't know that at the beginning. All I knew was whether it opened up or down. But in vertex form, I already know the vertex. So really, it helps me out just a little bit more, but graphing it is exactly the same. So I'm going to plot the points. Be negative 3, positive 6, negative 2, positive 3, negative 1, positive 2, 0, 3, and 1, 6. Okay, I'm going to draw a line through all of my, not a line, but a little parabola through all of my points here. Okay, now does this have any x-intercepts? No, because it never crosses my x-axis. It's above it, so it's never going to cross. All right, so let's go ahead and identify the y-intercept here. So the y-intercept is where the graph crosses the y-axis. So here is my y-axis. What point does it cross the y-axis? At 0, positive 3. Now, did I already know that before graphing? I didn't. Now, in standard form, the c value tells me my y-intercept, but in vertex form, it does not. So I do not know my y-intercept until I either graph it or see it on my table. The only thing that this form tells me is whether it opens up or down or what my vertex is. All right, and then we'll go ahead and identify our domain and range. Now, domain here is still going to be all real numbers because it still goes infinitely to the left and to the right on my x-axis. Forever, it's going to keep getting wider and wider. My range here, it always starts with a y because remember, domain is x and range is your y values. Now, does this parabola open up or down? It opens up. So it's going to be greater than or equal to, because it does go through the most bottom point. Now, what is the most bottom point? Well, it's going to be positive 2. So you're saying that all of your y values are greater than positive 2. Is that true? Yeah, because at positive 2, all of my y values are above that. Nothing on my graph is below that. All right. And don't forget that, that this number is always the same as the y value in your vertex. All right, moving on to number 2. We're going to graph this. Now, before graphing it, what do I already know? Well, I know it's going to open down. How do I already know that? Well, because my a value here is -1. So I know it's going to open down. Okay? And also, I didn't really ask about min or max here, but hopefully we have remembered that from the previous notes. Remember, this would be a minimum, and it's whatever our minimum value is. So in this case, I have a min. And the minimum value here is going to be whatever your lowest value is, your lowest y value. So our minimum value here is going to be positive 2. So I'll go ahead and identify that because I forgot to mention it over here. Okay. So I know it's going to open down in this one because a is negative. I know that for a fact. But what else do I know? Well, I also know the vertex. The vertex here is going to be positive 2, positive 3. Remember, the number on the inside is opposite, which means I already know my axis of symmetry is going to be positive 2 because those numbers, the x's, are the same. Now, do I know my y-intercept before graphing this? I do not. I only know that if it's in standard form, but it's in vertex form, so I don't know that. So let's go ahead and graph this. Now, you want to graph this exactly the way that you would say it, okay? So what would you say first? You would say negative. Let me choose a different color, actually. I'm going to choose this one. This is negative. You would do parentheses x minus 2 squared plus 3. So the negative and the minus sign are different, and you want to make sure that you type in the correct one. You don't want to type minus minus, and you don't want to type negative negative. So you would type it in exactly how you would say it. All right. So let's go ahead and go to our calculator and graph this. So I want to go to y equals, and I'm going to clear what I already have. I can have negative. Remember, the negative button is down here. And you can type in a 1 if you want to type in -1, but it doesn't matter. So you can either type it like this, or you can just start typing in your parentheses and put x minus, x minus, is it -2? -2. Now that is a minus, so notice how the negative sign is shorter than the minus sign. So they are very different in the calculator. Parentheses squared plus 3. Okay, so negative, and then a minus, there's a negative here and there's a minus. And then I'm going to do second graph to find my table. Now I don't really have to find my twin, or my one without a twin, because my vertex already told me that. I know that it's going to be 2, 3. I know that's the one in the middle of my rainbow already without even starting, because it's my vertex from vertex form. But notice it is the center of my rainbow here. 3 is the one in the center, so 2, 3 is my center point on my table. So, now this is knowledge that I already know before starting, because I knew the vertex before even graphing. All right, so I'm going to put the two numbers below, which are going to be 3, 2, and 4, -1. And then the two numbers above are 1, 2, and 0, -1. I need to move these down because it's bothering me. I'm so sorry. -1, 0, 1, 2, 3. Just kidding. It starts at 0. 0, 1, 2, 3, 4. And I know that middle point was 2, 3. And then I have -1, +2, 2, -1. And again, these numbers should always be the same because it's supposed to be a rainbow. All right, we have 0, -1, 1, +2, 2, +3, 3, +2, and 4, -1. Now, was I right about this opening down? Well, yeah, because my A is negative. If A is negative, it's going to open down. So I'm going to go ahead and draw my quadratic here, my parabola. Okay, did my best there. I know it's not perfect. All right, now moving on, we're going to identify our y-intercept. Well, our y-intercept is where the graph crosses the y-axis, right? Well, what point does it cross? Well, it crosses at 0, -1. Our domain here is going to be all real numbers, and our range is going to be y is less than or equal to, because it opens down, it's going to be less than. So you're saying all of your y values are less than what y value? It's going to be less than the 3, because all of your y values, if you look on the y-axis, because range is y, all of your y values are less, because your graph doesn't go higher than 3. Now, it's also the same number as the y value in your vertex, but I did want to mention that. Now let's talk about whether this is a maximum or a minimum. Well, this is going to be a maximum graph, and the maximum value, okay, because you're saying that it's a maximum, so what's the maximum value? Well, your maximum value on this quadratic is a 3. It's the highest it goes. For here, it's the lowest it goes because it's a minimum. So if you tell me it's a minimum, then what is that minimum value? Here, if this is a maximum, then what's that maximum value? All right, moving on, last one. Now I do have a star next to this one because there is a fraction. I do want to show you a couple of ways that you can type this in the calculator. Before we start that though, do you think this is going to open up or down? This is going to open up because your A is a positive. Even if it's a fraction, it's still positive, so it's going to open up. But what's our vertex here? We're missing a number, aren't we? Well, if we're missing something and something's not there, then what's that as a number? It's 0, right? So there's technically a 0 here, they just don't write it. So that means my vertex, well, what would that be? Well, that's going to be the point 3. Is it 3? Or is it -3? It's going to be the point -3, comma 0. Now, they didn't write the 0 there, right? They didn't write it there. But it is there, they just didn't write it because they don't need to. But our vertex is -3, 0. Remember, the inside is always opposite, which means my axis of symmetry is going to be -3. All right. So now I'm going to go ahead and graph this. Now, the 1/2 is written as a fraction. So here's the deal, right? If you want to see fractions when you see this screen here, then you would type in a fraction. But if you want to see decimals, then you want to type in something else. So I'll show you what I mean. So the normal way is I do alpha y equals, I hit fraction, I have 1/2, parentheses x plus 3 squared. If I do it this way and I type in a fraction like that with the what's it called? With the cheat right here, with the little shortcut, if I do it that way, then when I go to my table, what do you notice about my y values? There's a bunch of fractions here. If I don't want to see those fractions, then I need to type it in a different way. So the way that I would type it is I would type 1 divided by 2, and then parentheses x plus 3 squared. So these are written very similarly, but here I did 1 divided by 2. So I typed in 1 divided by 2. And notice I typed this in the red. So see what happens in the red column. Well, in the red columns, I have decimals. And I prefer decimals because it's easier for me to know where to graph. So I'm going to type it in that way. 1 divided by 2, parentheses x plus 3, parentheses squared. Whoops, squared. Second graph to go to my table. Now I have a bunch of decimals. Now without graphing this, I knew that my vertex was -3, 0. So I know that's going to be the middle of my rainbow already. Well, -3, 0 is right here. And see how it doesn't have a twin? 0.5, 0.5, 2, 2. Those have twins, but 0 doesn't. So then I'm going to make my table, pick the two numbers below and two numbers above. Okay, so let me go ahead and make my table here. My x and my y. I know that -3, 0 is in the center. The two numbers below would be -2.5 and -1, 2. The two numbers above are -4.5 and -5, 2. Remember, these should make a rainbow. They're matching with each other. So I'm going to go ahead and graph these. Now, there is a star for this problem because of two reasons. One, the decimals when we graph. And two, because there's not a number here. But there's also one more thing, and there's another reason why I started. And I'll talk about it just in a second. So I'm going to graph -5, so it's going to be to the left 5, up 2, -4, and then a half. So that's not quite to 1, it's halfway, right? And then I'm going to graph -3, 0, so that's going to be on the x-axis there. -2.5, and then -1, +2. So I have the graph like that right there. Okay, now the next question it asks me is, what's the y-intercept? Well, do I have a point that crosses the y-axis here yet? Do you see a point that crosses the y-axis? No, but is it going to cross eventually? Yes. Because it's going to cross eventually, then there is a y-intercept. We just don't have it on our graph because we didn't graph all the points. So then what do? Well, what does a y-intercept always look like as a point? It's always 0, number. The x value is always 0. So in our calculator, you want to search for 0, number. So I'm going to go to my calculator real quick, and I'm going to show you. You want your x to be 0. 0, number. My y-intercept is 0, 4.5. So I can always find the y-intercept even without a graph if I have the table. 0, 4.5. Again, did we get that from this graph here? No, we had to go search our table for it. But remember, in the calculator, you always have 0, number. Okay, now our domain here is going to be all real numbers once again. Now this quadratic opens up, so it's going to be y is greater than or equal to. And then you're saying that all of your y values are greater than what y value? Well, they're all greater or equal to 0 because it is equal to the 0 down here. It does go through 0. Okay, so is this a maximum or a minimum graph? This is going to be a minimum graph. So what is that minimum value? Well, your minimum value here is going to be the lowest, because it's a minimum, the lowest y value. And in this case, it is 0. All right, if you have any questions with graphing vertex form, please ask me. It is almost identical to graphing standard form. The only difference is that you already know the vertex without even graphing it. Again, if you have any questions, just please feel free to come in for tutoring.